And so what I want to do first today is I want to define the new rules when we use arithmetic with complex numbers. Before we jump into the rules for arithmetic though, there's a very a simple kind of introduction that we have to look at, and it's talking about equality. Right? If you look at numbers, it's very easy to see when they're equal to each other. Yeah. If I just have a number, it's equal to some other number. With fractions though, fractions is a little bit different though, right? Because half, what can half also be? Half could also be 4 and 8, right? It could be 8 and 16, it can be all these other things. And initially, again, it seems kind of strange, like why is 1 equal to 4? Why is 2 equal to 8, right? They're not, right? But when you expand to this new number system, we create new contexts. So for complex numbers, you can jot this down for me, right? Two complex numbers are equal if, the two complex numbers are equal if and only if their real parts are equal and imaginary parts are equal. Mathematically, how would we represent that? Well, if we have two complex numbers, Z and W. By the way, the implication is if I write letters like Z and W, that we're assuming that they're a part of the complex numbers, right? But then Z, we know we can represent in this particular way, where X and Y are real. That's kind of an assumption with the notation that we have, right? So if I have these two complex numbers, Z and W, then if they are equal, then the real part of Z is equal to the real part of W. And the real part of W, sorry, not the real part, the imaginary part of W, or Z really, imaginary part of Z is equal to the imaginary part of W as well. Okay, that's all well and good, and that kind of seems self-explanatory. How do we use this to solve kind of problems, right? Let's look at this situation. Let's look at these two examples. We're talking about the equality of complex numbers, right? And this statement is saying that they're equal. And if they are equal, then we know some important things. We know that the real parts are the same, and we know that the imaginary parts are the same. When you're looking at this then, what can we do with these two values here, with X and Y?
Separate them into two different equations. Like
yeah, right. You can just say, hang on, well, what's the real part of this guy? Well, that's the real part. And what's the real part of this guy?
X.
It's just X. And what's the imaginary part of this? Well, it's the value that's in front or multiplied by my imaginary number. That's this guy here. And Y is over here, right? So in this situation, right, I can just identify them. And I can say, well, I can tell you that then X is equal to 4 and that Y is equal to 5, okay? That's for a situation like this, where I'm just kind of comparing, okay, what are the real parts, what are the imaginary parts there, okay? It becomes a bit tricky when you have something like this. And my tip for you is when you're starting out to solve these kinds of problems, is that this imaginary unit, I, we can treat as a variable. Right? We can treat it as a variable and do the normal operations we would normally do. So I can't make any direct comparisons at the moment because remember, a complex number has to be in this form here. It has to be very clear, X plus yi. You can't just kind of say, oh yeah, there's some values here and there's an I there. So, is this the real part? You have to make it very clear that it's in this form, okay, before you start doing any comparisons, right? So with this one over here, let's actually expand it out first before we do anything. So this guy, let's multiply him out. So like I said, kind of treating him like your normal expansions. We'll get yi minus I. Yeah.
Can you add it to the other side?
Yeah, right? These are just equations, right? With the goal of identifying what are the values for X and Y. You want this in a particular form where you can make direct comparisons between them easily, okay? And if I want to make it very easy to compare them, well, I want to think about balancing my equations so that I can do that. In this situation, I'm just going to add I to both sides, right? If I add I to both sides, again, like treating it like a variable. If I add I to both sides, I get minus 2 minus 2i equals to X plus yi. Now, yeah.
A long way around. Like you did the long way around.
Okay, so what else could you have done?
You just like y minus 1
Yeah.
equals 3.
Yeah, you could do that as well. You can make a comparison here and here, potentially. Yeah?
To be honest, this way makes more sense in my head.
It does.
Yeah. Either way, right? I think the danger with potentially doing stuff like this is that questions later on with different formats and stuff, which may not exactly be in that form, then you may present your own problems and things like that. Yeah, so in this situation, then we can make a direct comparison, right? We can see x is the same as -2, and then y is the same as -2 as well. Is that what we get? Cool, awesome.
So x equals y.
X equals y in this situation, yeah. Any questions so far? Jot that down for me. And then page 9, we've got a couple more examples for you to try.
Big book. So this is all for just one topic. So
For this term, potentially, yeah.
all of stuff. Which page?
Page 9.
Why are you staring?
Oh, I'm just trying to think which way is better. Do you find that way of comparing these guys easier, do you reckon?
It's the first thing my mind jumped to.
Yeah.
Doing it like that makes more sense.
Okay. Yeah, no, like I'm happy with either way, to be honest. Because I didn't see that way initially. So I guess it's kind of how you see things, right? So if you saw that comparison is more immediate for you, then yeah, by all means do that. Just be aware when you can actually make that comparison, because you won't necessarily always be able to, right? Like if they snuck in some other variable over here, then you can't just kind of compare the values that are there, right?
Oh, yeah. Like with this,
Yeah, what is that one?
we use a bit more.
How'd you go with this one, James?
So I made the comparison between 2 and x minus 1.
Okay, I think that's probably the best way actually moving forward. I've changed my mind. I think that is slightly better, right? Provided that you are careful with when you use it, yeah, making sure you're actually comparing the real components. So you're saying, all right, all the real parts are the parts that are separate from I. So my real parts are here, so 2 and x minus 1. And then what would your other comparison be? You've got 2y plus 3 and you're comparing it with I, right? Okay. Be careful though, again, this is where you got to be careful, because if you're comparing with I, what's the actual imaginary part of this, right? This is 2y plus 3, so the imaginary part of this guy is just 1, right? Yeah, so just make a note of that, right? Okay, so 2 is equal to x minus 1, and so we've got x is equal to 3. And this guy over here, we've got...
1's equal to 2y plus 3.
Right, yeah. And we can do some rearranging. Minus 1. Cool. Okay. So, equality of complex numbers. We know two complex numbers are equal when their real parts and imaginary parts are equal. And that also allows us to find unknown variables if we know that two complex numbers are equal. Okay.
Well, first I expanded it.
Yeah.
So the last part is going to be expanded.
Mm-hmm.
So it's x, y minus y.
Yeah, and what did you do after that?
And then I did 2 equals to x plus y because they have to be separate.
Yeah.
And 3i equals to x minus yi. Or just 3 equals to x minus y.
Ah, so you did expand it and then you did compare them again afterwards, right? Do you notice that?
Do I? Cool. Yeah, well, let's compare.
So as in like, so you expanded this out.
Yeah.
And so what did you? You said that 2 is equal to this.
Yeah.
And then 3 was equal to, 3i is equal to that? Is that kind of what you did? Yeah.
Yeah, but I left out the i's. Is that okay to do? Because
Yeah, so I probably, yeah.
okay, right here, yeah.
Sorry? Yeah.
So you could have just left it.
Mm. So actually, like when I did that one before, I kind of saw the bracket and I said, yeah, let's just expand it. And that was maybe not the best move on my part, because when you expand things, you can sometimes make it trickier for yourself. And like in this situation. I think the key part is just recognizing what is the real part and what is the imaginary part. So from this step here, yeah, you don't actually have to expand. You can just say 2 is equal to x plus y because that's the real component, that's separate from I. And then 3 is equivalent to x minus y, which is essentially what you did anyway, right? But you just expanded afterwards, right? And then you'll realize that you do have to end up creating a simultaneous, right? You'll have to say that x plus y is equal to 2 and x minus y is equal to 3. What's the easiest way to solve this one? Add them together, yeah, right. So we'll take 1 and 2, we'll do 1 plus 2. And if you see that these guys will cancel out, so we'll get that 2x is equal to 5, or x is equal to 5 on 2. And so that means y is equal to -5 on 2, -half?
Yes.
So, yeah.